Hello all. Today we are solving LeetCode problem number 3719, longest balance subarray part 1. So you are given an integer array which is called as nums, and a subarray is called a balanced if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. So which means if you are given an array for yeah, we can run through example 1. So we are given an array 2 5 4 3 and odd distinct odd numbers or 5 and 3 and a distinct even or 2 and 4. So we have to return the longest balance subarray. So in this case you have only 4 values, and this both odd length of odd and length of even distinct sub values are same, and due to which it lies in the length of 4, and due to which we are returning 4 as the output. So if you take example 2, this is completely different because you can see here you have 3 and 5 as the distinct subarray for odd, right? And you have 2 and 4 as for even, and you have extra 2 which is the duplicate value of the 2 already, which is already existing in the even set, right? But since the subarray has this subarray, that is 3 2 2 5 4, the complete array has the distinct odd and distinct even size as equal, which is nothing but 2. Size of this is 2 and size of this is 2. So since it is equal, the maximum length for this subarray is the 5. So it is due to this reason we are returning the answer as 5. So this is the tricky part here, but here we are going to solve this problem with the brute force approach. So what I'm thinking here is just to follow to form all the possible subarrays and check. This is the first part, and check balanced condition. And you can you use the result value and find the maximum length of the balanced subarray, right? So use max function to track down the longest length of subarray. So this is how we are going to solve. I will explain how we are going to find all the possible subarrays. So we have, let us solve the example 3. So which is we have 1 2 3 and this is 2. So we start from this the index position. Let me change the color, and the index position 0 1 2 3. So first subarray will be 1, which is nothing but we start from 0, and the first subarray will be 1, right? And the next one will be 1 2, and the next will be 1 2 3, and the next will be 1 2 3 2, right? And then in the next, from the next iteration, this will be the next subarray. Let me change the color. So this will be the next subarray, and this will be the next one, and finally this one, and next we will shrink the length again. So we will start with this first, the new subarray, and this, and there we go. Like, we will repeat the same pattern, and we will be finding out all the possible subarrays. And this will take 2 pointers, which is I and j, right? So we will use this, and this will consume 2 for loops, nested for loops. So the time complexity will be big O of n square for solving this, or for finding out this subarrays. And for tracking down the odd and even, we use set, because we are finding out distinct, right? So we need the unique values. So to find out or to track down the unique values, we need to use set. So we will be using two sets which will track down odd and even. So with this, we will I will show the dry run for this problem. So we have one here and we will have odd set, right? Maybe I can have it as odd set, sorry, odd even, right? So since it is 1, the odd value will be 1 here and this will be 0, so it doesn't satisfy the condition for balance, which is the length of odd is not equal to length of even. So this will not satisfy the condition, so we will not calculate. So when this condition is satisfied, calculate length. So how do we calculate? We will use the I pointer will be the left one and the j pointer will be the right one. So this will be j minus I plus 1. So this is how we calculate length, right? And we store it in result equal to max of the existing result and the new one, which is j minus I plus 1. So this is how we calculate. So for the first 1 and 2, this is this function will not execute. So in this next subarray we have 1 and 2, so the even will be 2, so the condition satisfies, so this executes. Then what happens here is you get the length, which is nothing but the j will be here and I will be here, so which is nothing but 0 and 1, so which is 1 minus 0 plus 1, which is equal to 2, so the rest will be updated to 2. So this is the maximum value. And next what happens is we come to this third iteration, which is nothing but the value here is 1, 2 and 3, right? So now odd will be 1 and 3 and even will be 2. So this does not satisfy the condition. So what we do is we move to the next one, which is nothing but 1, 2, 3, 2, right? So let me change the color here. So now odd is the distinct odd will be 1 and 3 and even will be again 2. So again this does not satisfy the condition and we move to the next one. So next set of subarray will be, this will be the possible one, yeah, the 2 and 2 3 and 2 3 2. So let me write down all those 3 here. So this will be 2 and 2 3 and 2 3 2, right? So for this we have only one value, which is even is filled, right, filled with 2, and odd is empty, nothing is there, so this does not work. And in this case even is equal to 2 and odd equal to 3, so which is length is the length here will be yeah, this satisfies. So j is equal to, let me check it here, j is equal to 2 and I will be 1. So hence this will be 2 minus 1 plus 1, which is nothing but 2. So since already the existing result value is 2, we will move to the next one. So now the even will be 2 and odd will be 3. We know that we will have only the distinct values here, but we have 2 2's here, but the way we track in the set, right? So here the values is only 2 as even and only 3 as odd. So the length is equal and this satisfies the condition. So now we have I here and j here. So I is equal to 1 and j is equal to 3. So hence what we will be getting here is j minus I plus 1 is nothing but 3 minus 1 plus 1, which is nothing but 3. So the result is equal to 3. So the new result is 3, and this will be the maximum. We have to repeat it again for the next set of subarray, but this is the end for this problem, and we will get 3 as the maximum value, and we will go ahead and return 3. So as I said, the time complexity for this problem will be big O of n square, and space complexity will be big O of 2n. Not exactly 2n, we will use, this will be less than, this will be n, because uh, we are using two sets, which is odd and even, which will have not exactly 2n times of the element. We will have at least half of the elements in each set, so which will be coming around big O of n. So with all this observation, let us go ahead and code this up. So n is equal to len of nums, and the result is equal to 0, just to track down. And for I in range, we start from we have 0 to n. So next, for j in range, start from I till n. Right, so now we have to declare the two sets to track down every value, so that should be done here. So odd equal to set, even equal to set. So now we will put down the balance condition. So if nums of before that we have to append the values in the set, right? So if nums of I is divided by modulo by 2 equals to 0, then this is even. So you append to even, so even dot add, we will add the nums of here, this should be nums of, okay, yeah, this should be nums of j, yeah, nums of j, right? So we add the values, and else this should be added to the odd. So add nums of j, right? So now the next one is we will check the balance condition. So if length of odd is equal to length of even, so in this case you will update the max value. So nothing but result is equal to max of the existing result, and you have the j minus I plus 1. So this will be the new length of the result, and now we will go ahead and return result. So let us submit this, run this and submit this. And there you go. Thank you.